Hey everyone, and welcome to The Explainer. I am your host, Dr. Kem, and today I am absolutely thrilled to present a lecture on the brilliant historical minds that literally shaped the bedrock of our modern reality. We're going to take a really detailed look at the Muslim men of science, whose groundbreaking discoveries, all born right in the middle of the Islamic Golden Age, laid down the foundation for, well, almost everything we rely on today.
So think about this for a second. What do modern smartphones, the eyeglasses you might be wearing right now, and the high-tech chemical labs synthesizing our modern medicines all have in common? I know, it kind of seems like a stretch to connect a digital device in your pocket to an ancient world of scholars. But the truth is, the fundamental principles making these everyday marvels possible trace directly back to the monumental breakthroughs of these exact scientific pioneers.
Okay, let's dive into this. Here is our roadmap for today. We're going to start with the dawn of modern science. Then we'll look at algorithms in the digital world, pioneers of chemistry and matter, the physics of light, revolutionizing the healing arts, and finally, we'll wrap up with their enduring scientific legacy.
Right. Section 1, the dawn of modern science.
Now, to really grasp the magnitude of these discoveries, we've got to zoom out and look at the historical shift that took place. We are talking about a massive leap from mere philosophical guesswork to rigorous empirical methods. It's like a continuous chain of innovation. Between the 8th and 14th centuries, the Islamic Golden Age was just in full swing. You had scholars in places like Baghdad synthesizing Greek, Persian, and Indian knowledge. By the 11th century, we get absolute masterworks like Avicenna's Canon of Medicine. But notice what happens in the 12th century. There's this massive movement to translate these Arabic texts into Latin, which basically acted as the spark for the European Renaissance. And as we'll see, this single unbroken thread of scientific inquiry leads directly to the 20th and 21st century Nobel laureate breakthroughs happening today.
Moving right along to Part 2, Algorithms and the Digital World.
If you've ever used a computer, typed into a search engine, or just scrolled on your smartphone, you are relying on the mathematical bedrock established by one incredible 9th century polymath. You know the word algorithm, right? It's not just some modern Silicon Valley buzzword. It is literally derived from Al-Khwarizmi, which is the Latinized name of the brilliant 9th century Persian mathematician Muhammad ibn Musa al-Khwarizmi. When his works detailing the Hindu-Arabic numeral system were translated into Latin, European scholars called the technique of doing arithmetic with these new numerals algoritmus. His very name became the foundation for the code running our entire modern world. Absolutely wild.
Imagine trying to do advanced math without any of our modern mathematical symbols. Well, Al-Khwarizmi didn't have them. In his 9th century manuscript, he wrote out his equations in full, complete sentences. And yet, in this very book, he presented the very first systematic solution for linear and quadratic equations. He even provided exhaustive geometric justifications for his methods. He essentially created a universal language for solving complex problems. And guess what else we get from that exact same book? Algebra. Yep, the word comes directly from the Arabic term al-Jabr, which means completion or rejoining. It refers to his revolutionary method of moving subtracted terms to the other side of an equation to balance it out. Because Al-Khwarizmi treated this as a totally independent mathematical discipline, he is rightly celebrated today as the absolute father of algebra.
Let's jump into Part 3, Pioneers of Chemistry and Matter.
Now, as Dr. Kem, I've got to say, this part of the lecture is my absolute favorite. The story gets incredibly dynamic here when we look at Jabir ibn Hayyan, an 8th century giant of science. Before Jabir, alchemy was heavily steeped in mysticism, magic, and frankly, theoretical guesswork. But Jabir completely flipped the script. He transformed alchemy into systematic chemistry. His entire framework was built on empirical observation, precise quantification, and reproducible experimentation. He famously insisted on using the balance, realizing that chemical reactions happen in precise proportions, centuries before modern stoichiometry was even a thing.
When you look at his practical applications, the breadth of his work is just staggering. Jabir practically invented the modern chemistry lab. He developed the alembic for distillation, a process we still use today for everything from purifying water to refining petroleum. He created crucibles, water baths, and the chemicals he discovered? We're talking sulfuric acid, nitric acid, hydrochloric acid, and aqua regia, which is a mixture so powerful it literally dissolves gold. These aren't just minor little finds. These are the foundational industrial chemicals of the modern world. There is absolutely no question why he's called the father of chemistry.
And that intense spirit of uncovering the secrets of matter, it definitely didn't stop in the 8th century. Fast forward to 1999 when Egyptian-born scientist Ahmed Zewail won the Nobel Prize in Chemistry. He built on that ancient legacy of precision by developing ultra-fast femtosecond lasers. This allowed us to capture chemical reactions at the smallest fraction of a second. Just think about that. The continuous line of inquiry from Jabir's crucibles all the way to Zewail's lasers is simply breathtaking.
Okay, part 4, the physics of light. Here we encounter a true visionary who quite literally changed how humanity sees the world. Meet Ibn al-Haytham, widely known in the West as Alhazen. Born back in the 10th century, he is universally recognized as the father of modern optics. But beyond just optics, he's frequently described as the world's first true scientist. Why? Because of his unyielding commitment to proving hypotheses with hard, confirmable experiments.
So, here is how he applied this groundbreaking method. At the time, the popular Greek theory was extremissive vision. That's the idea that our eyes actively shot out rays of light to see things. Ibn al-Haytham completely rejected this. He formulated a new hypothesis and built painstaking experiments, including early camera obscura devices, to prove that vision is actually intramissive, meaning light bounces off objects and travels in straight lines into our eyes. He documented all of this in his Book of Optics, acting as a true pioneer of the scientific method a full 5 centuries before Renaissance scientists like Galileo and Descartes, who, by the way, heavily cited his work later on.
And once again, this deep legacy of unraveling the fundamental physics of our universe continues today. Muhammad Abdus Salam, the first Muslim scientist to win a Nobel Prize back in 1979, proved that the weak nuclear force and the electromagnetic force are actually just two manifestations of the exact same underlying force. He beautifully carried forward that grand tradition of looking at the universe, questioning its rules, and proving them mathematically.
Section 5. Revolutionizing the healing arts.
Now, we cannot talk about Muslim men of science who saved the world without talking about the giants of medicine. The main name you need to know here is Avicenna, or Ibn Sina. In the year 1025, he pulled off an unimaginable feat. He took the scattered medical knowledge of the Greco-Roman world, the Persian world, Chinese medicine, and Indian medicine, combined it all with his own vast empirical observations, and created a massive 5-book encyclopedia. He covered the whole shebang, from the properties of specific drugs to herbal remedies and highly advanced surgical interventions.
He called this masterpiece the Canon of Medicine, and it became the standard textbook for teaching in European universities into the early modern period. Just let that sink in for a second. For over 600 years, if you were a medical student anywhere in Europe or the Middle East, Avicenna's structured, holistic, and empirical guide was your absolute medical Bible. It is arguably one of the most influential medical documents ever written in all of human history.
Finally, Part 6, an enduring scientific legacy.
The history we've discussed today isn't just dusty trivia, it's the very architecture of modern scientific excellence. From Abdus Salam unifying fundamental forces to Ahmed Zewail mapping chemical dynamics in femtoseconds. We also have Aziz Sankar, who won for mapping how our cells repair damaged DNA, and Munji Bawendi, who recently won for his groundbreaking discovery and synthesis of quantum dots. These contemporary pioneers are walking the exact same path laid out by Al-Khwarizmi, Jabir, and Ibn al-Haytham.
So what's the ultimate takeaway for us? Well, the blueprint these scientists gave the world is a strict commitment to empirical observation and rigorous testing. It's the application of systematic mathematical reasoning to the physical world. It's the interdisciplinary synthesis of knowledge, not treating subjects in isolation, but blending physics, chemistry, and medicine together. And perhaps most importantly, it's a deep dedication to global collaboration and knowledge exchange. They translated the Greeks, the Indians, the Persians, and then the Europeans translated them. Science is a continuous global human endeavor.
I really want to leave you with a final thought to chew on. How can the globally collaborative and interdisciplinary spirit of these historical scientific pioneers help us solve today's greatest existential challenges? Whether it's climate change, navigating new diseases, or unlocking quantum computing, the methodology we need to survive and thrive was perfected by these brilliant minds centuries ago. We just need to keep applying it. Thank you so much for joining me on this deep dive into the Explainer today. I'm Dr. Kem, reminding you to keep questioning, keep experimenting, and keep learning.